Welcome back to another video. It's your boy, Basement Math Lab, and today we're going to be looking at cosine law. Now, if you didn't watch the sine law video before this, go do it, because that's more important to know than the cosine law. Because the cosine law is kind of in a way, a niche kind of way of solving for triangles, because there's only really two situations where you would use cosine law. And this situation down here is one of them. Now, the reason why I use cosine law is because you can't use sine law, right? Because sine law requires two letter pairs, right? This A and this A are a letter pair. But as you can see, there's a value for this A, but not for this A. So you can't use this letter pair, you can't use the C's as a letter pair, and you can't use the B's as a letter pair, because there's just no value for the other one. And it's not like where you had two angles and you could use subtraction to figure out the subtraction from 180 to figure out the degrees of the last angle. So this is a kind of like completely different situation where usually, like, if you want to use sine law, you can't, because there's just not enough information. You don't have the letter pair. And so the cosine law are these two equations at the top. Now this equation is for side lengths, and this equation is for angles. Now, mainly in physics, you're going to be using the cosine law to find a side rather than an angle, but I'm going to show you both either way. And so, first we need to find a side, because in this situation, you just need to find a side, because, well, other angles aren't really that important right now, so we'll find a side. You can use the angle one for a different situation, but it's better to use the side one. Anyways, I'm rambling. So, this equation, you have A, and that is equal to this side squared plus this side squared minus 2 times this side times this side times the cos of A. And all of that square, taking the square root of all of that. So, let's go and do it. I'll write it down and I'll be back in no time. So here's the equation with all of the subbed in values. As you can see over here, the b from the b squared is this b, and then the c, and then obviously the cos of 48, the a angle equals 48, and then 2 times b and c. So if you just look at both of these, you'll see that all the values have been subbed in accordingly. Now what we're going to do is we can just square these as our first step. So a is equal to, I'm just going to do a quick cut and figure this out, and then I'll be back. Okay, so those are the squares of 35 and 25. They're 1,225 and 625. Now, the reason I didn't do this part yet is, well, for the video, but also because the chances of cos and sine and tan all being like really big decimal numbers are pretty high. So, having to like round them off or whatever won't give you the most accurate result. It's much better to put it in your calculator. And so, at least in my calculator, this will work in kind of a strange way as opposed to some other people's calculator. But if you don't have this calculator, I highly recommend it. It's Texas Instruments. It's a very good calculator. And so how you do this is you will put 1,225, and I'm actually just going to do a cut and then show you the finished product. You know what, actually I changed my mind. I'm going to do this with you because there is kind of an important lesson to be learned here. So as we know, BEDMAS follows certain rules, and so what I usually like to do with a problem like this is I put brackets around the first addition problem, and we're going to have to do that for when we find a missing angle, because that will be very important. I'm not sure if you need to do it now. I mean, you could try it out, see if it gives you the same answer, but whatever. And then you can do plus and 625. And then we can close the brackets there, and then we're going to be subtracting 2 times 35, sorry, you can't really see that, times 25, and then multiply it again by cos of 48. So over here, you will see the whole thing. So we have the square of b and c added together over here. Then we subtract 2 times the length of b, which was 35, times the length of c, which was 25, and then times the cos of a, which was 48. And then when we press equal, we get 679.02. So a would be equal to the square root of 679.02. Now, obviously, this has a lot of decimals, and there's a lot of room for error. So, some calculators work different from mine, but how I do it on this calculator is I actually just press clear here, and then I go to second function and square root, and then I go second function again and go down here where it says answer. Because the way that this calculator works, it saves the previous answer in memory, so you could use it for the next kind of equation. And it works very well in this situation, because I just press equals here, and we get 26.05, which we will just round to 26. And that would be centimeters. So 26 centimeters. And that would be the length of this A, which, if I am checking my notes, that is correct. So, well, it was rounded a bit differently, but yes, that is correct. So that is how you find a missing side, but a missing angle is a much different story, and I will find an example for that. So when you use cosine law to find an angle, you'll probably find yourself in a situation that is like this. And this is a very strange situation because you know the length of the sides, but you don't know any of the angles. But there is a way that you can solve this, and it is by using this equation right here. So we have, for this equation, cos A equals b squared plus c squared minus a squared over 2bc. So the cos of this angle is this squared plus this squared, this squared plus this squared minus this squared divided by 2 times this times this. So I'm going to just quickly show you that. So as you can see, I subbed in the values. This is the value of A, because it is opposite to the angle A. This is the value of B, opposite to angle B, and this is value C, opposite to C. And you can see here, this B right here, also put it in there, and then the C there is that, and then this A squared is the opposite of the A angle. And now from here, you have to go into your calculator. And this is a very kind of tricky thing. And because you have to use a lot of brackets. But for this one, we can kind of skip one of the steps where I just do this, and we can go right to the inverse cos, right? So we know that if we want to get A on its own, we have to do inverse cos. So we would go second function, and then inverse cos. And then over here, we would do another set of brackets. And we would go, 20 squared, and then plus 17 squared minus 30 squared. Okay? So here we got 20 squared plus 17 squared minus 30 squared. And then at the end of this, we put another bracket. Okay? So it's taking the cos of everything that's in the brackets, right? And whoa, hold on, I did something bad. Give me just a second. Okay, I made a little tiny boob there, but we have the same thing. Inverse cos of 20 squared plus 17 squared minus 30 squared. And then here at the end, we know that we have to divide by this. So we press the divide symbol, and then we start another bracket. Now this is really important, well, at least for this calculator, because it will not work if you don't put this bracket. So this is very important. So then we do 2 times, and then we know it's 20, and then times, and then 17. And then we do a bracket closing that off, and then another bracket closing the whole thing off. Closing the whole cos. See, because here we had these two brackets, right? And so at the end, we also have to put these two brackets. And so when we press equal, we should get the value of A and not cos A. And the value of A should be 108. And I actually haven't tested this out yet. And let's see if it is 108.1. It should be. And it is 108.1 if you round that. So the value of A would be 108.1 degrees. And that would be how you solve for an angle. And this part, cosine law really is not complicated as long as you know your calculator, you know what works. When you do certain questions that you know